All right, so now we're on part 2 of Journal 34. So if you haven't watched part 1, please go watch part 1 before you watch this video. Okay, so if you watched part 1, some of you might be thinking, okay, what was the point of listing out all those possible real zeros? Because I didn't get the exact x-intercepts. I didn't get the x-intercepts. I just found the possible ones that they could be. What was the point of doing that? Well, let's do that here with this problem and see how the listing out all the possible real zeros is helpful when solving for the x-intercepts. So here is a problem, and also this problem here is actually number 5 in packet 7 on page 6. So if you want to put this in your packet later, just the answers, and just show all the work in your journal, that's completely fine. So you can even just write your answers on the packet and just have the work done in your journal instead. So that being said, let's get started with this problem here. So in this problem, what is the degree of this function? Well, that's the highest power. So the highest power here is 3. So remember that the degree of the function tells us how many solutions we should have, or how many zeros we should have in the end. So we should have 3 zeros, so 3 solutions for x in the very end. So in this case, what we're going to do, because we're not given a factor to use synthetic division on, we are going to list all the possible real zeros. So in other words, using that formula again. If you remember, what we had to do is write the factors of the what was it? The factors of the constant. So that's that n number usually on the function, and the factors of the leading coefficient. So let's go ahead and do that. So for our factors of our constant, here's our constant. It's our 12. Let me use a highlighter. There we go. It's our 12, right? So that's our leading constant. And our leading coefficient is, well, what's the number in front of this x to the 3rd power? Well, it's just 1, right? So in this case, we have 1 in front. Let me actually write a 1. If I can grab a pen. Oh, 1. Okay, so let's find all the factors for the constant. So for the constant here, we just ignore the sign, because the sign is going to be taken care of with the plus or minus. So you just really want the 12. Let me make this a little bit more clear so that we know. So we just need to know the factors of 12, not that negative sign. So factors of 12. So let's start with the number 1. And we're going to go all the way up to 12. So 1 divides into 12, 2 divides into 12, 3 also divides into 12, 4 divides into 12. 5 doesn't, 6 does though, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't, and 11 doesn't, but 12 does. And so that's all the factors of just 12. So numbers that divide into 12. Now we're going to think of numbers that divide into 1. Well, that's easy peasy. The only thing that divides into 1 is 1. So now we are going to list out all the possible real zeros. But in this case, because we're dividing all of these by 1, that's just going to be 1 divided by 1, 2 divided by 2. So let's write them out here. I'm going to make some more room by erasing this guy here. You can put it probably more to the edge here when you're writing this in your notes. So we have plus or minus 1. If we take 1 and divide it with 1, 2 divided by 1 gives you 2, plus or minus 2. If we divide 3 with 1, we get 3. If we divide 4 by 1, we get 4. Basically, it's all the numbers in the top, right, if we divide them all out. So here are all the possible real zeros. But remember, the degree of the function is 3, so not all of these could be the real possible zeros, only 3 of them could be. But which 3 are they? Well, we can figure this out by graphing it. So let's graph. All right, so let's go back to what we just found. So in the calculator, we confirm that x equals -4, so that's one root, or 1, 0, and x equals -1, and x equals -3. In other words, these are your x-intercepts, or where the graph crosses at the x-axis. So these are your zeros. And we're done. Oh, but I do want to mention here, right? Why did I know that I'm done? Well, that's because I got 3 x-intercepts and my degree of the function was 3, so I know I've maxed out. There's no more other x-intercept that there should be out there, right? So since I have 3 x values, I'm done because that's the highest solution that I should possibly get. Okay, now I'm done.